So a rose curve has two different forms as well. Again, these are functions. R is a function of theta. So one form is R equals A cosine n times theta. Another form is R equals A sine of n times theta. And they look more like daisies than roses, but they have petals associated with them. N is a counting number, greater than 1. So if n is even, turns out you have 2n petals in your graph. That's handy to know if you're not using a calculator. So if n is even, then there are 2n petals. How do you spell petal of a flower? With a D. No. A D or a T? It's a T. It is a T. D I'm wrong. I usually get it right, but once in a while I get it wrong. You're right. It is T. 2n petals. I think last night I spelled it wrong. Darn. Nobody said anything. It's a very quiet night class thing. I think they're mad they have to be there for 2.5 hours. Twice a week, yeah. I told them they're crazy for taking that class. But 2n petals. So if you have like R equals 1 sine of 2 theta, you're actually going to have 4 petals because n would be 2. But surprisingly enough, if n is odd, then n is the number of petals. Again, not something you have to memorize if you're graphing it on the calculator, only if you're graphing it by hand. Okay, so let's do an example to close it out. And then I'll show you a couple other things online because this won't quite be enough examples, but there's other material you can look at. If r is equal to 3 cosine of 2 theta, first of all, what's n? N is equal to 2. So how many petals? It's even. N is even. So there are 4 petals. We expect 4 petals. So when you graph it on the calculator, I'll do that, and then I'll show you how to do it by hand. So what did we say it was? 3, yeah. So there you go. Go to y equals, clear out what's there, and then go 3 cosine 2 theta. Again, make sure you're in radian mode. It might work in degree mode, the newer calculators, but the old ones won't. 3 cosine of 2 theta, and then we'll go to zoom number 6, and then we might need to zoom in. So there's your 4 petals. Is it a rose? Well, it's called a rose curve. That was kind of an evil laugh. Okay. Let's go out to -4 so we can see the whole graph. So I went to window. I'm just playing with the min and max on both. So if we were able to see I zoomed in, though, and then you couldn't. So there it is. So that's a more accurate picture right there. Okay, so how do you do it if for some reason you're not allowed to use a calculator? Well, you do have to know that trick. N is even, so there are going to be twice as many petals as whatever number n is. So you know there's 4 of them, right? Now these things are incredibly symmetrical. And the tip of any petal is the furthest that the graph gets from the origin. Knowing that allows you kind of a quick shortcut for graphing these. Knowing that there are 4 petals, and knowing that the furthest this thing gets from the origin, any petal, will be the tip of any petal. So we can predict, based on that, at which angle one of the petals will be. So bear with me here. What's the biggest, and it'll make sense after I explain it a couple of times. What's the biggest this can get? What's the biggest 3 cosine of 2 theta can get? In other words, what's the biggest r can get? What's the biggest cosine can get? 1 times 3? 3. The biggest that thing can get is 3. The furthest distance any petal can be from the origin is 3. The tip of any petal is a distance of 3 from the origin. That's what I'm saying. Does that make sense? Okay. Then knowing that, I can find the angle at which the tip should be located. How? Well, I know that I know how to solve this little equation. The cosine of 2 theta equals 1. When does the cosine equal 1? In other words, that's when cosine's the biggest, right? When cosine of 2 theta is equal to 1. When the smallest angle for which that happens is when the input is 0, right? Oh, so when does 2 theta equal 0? When theta equals 0. So I can confidently predict that a tip of one of the petals will be in the direction of 0. Let's use degrees here because it's easier to contemplate. Will be at 0 radians, or 0 degrees. And that means, I know the furthest distance I have to go out then is 3 in the direction of 0. 1, 2, 3. So that's the tip of one of my petals. So if you don't believe me, go to your graph. Look, 1, 2, 3, right? Now, here's the quick and dirty shortcut. It's not really dirty, it's just quick. Draw the petal. If you're just after a real quick sketch, don't worry about how thick it is, just draw it. So I don't know how thick it is, but I'll just, I could plot points to get an idea, but if I'm just after a real quick sketch, there's a petal, right? It may be too thin, it may be too thick, but we're talking a real quick sketch. How many of the copies of those are there? Everything's very symmetrical. All of the petals are the same shape. There's 3 more of these, so 4 altogether, right? Well, they occur at angles evenly distributed among one full rotation. So if there's 4 of them, the next tip should occur 90 degrees away. Remember that trick? It's the same trick we used when finding the roots of a complex number? Same exact trick. So there's 4 petals. Divide 360 by 4, you get 90 degrees. The next tip is 90 degrees away. And since we started at 0, you can just rotate this tip 90 degrees. There's a tip. Just try and draw a copy of that first petal. It's going to look exactly the same. Now the next tip will be 90 degrees away. So make sure that was right. 1, 2, 3, yep, draw that petal. Same, a copy of the previous petal. The next tip is 90 degrees away. Draw that petal. Okay? Now that's a quick way to do it, and it's sufficient in most cases. Now, it's a little bit more difficult if it's sine instead of cosine. If it's sine of 2 theta, so let's say r equals 3 sine of 2 theta, then when is sine at its, what's the biggest value of sine? It's also 1, right? But it occurs at 90 degrees, right? So you'd have to take 2 theta, instead of setting it equal to 0, you'd have to set it equal to 90, and you'd get theta is equal to 45. So instead of putting the tip, this first tip at 0, you'd put it at 45, and then use the same trick and rotate 90 degrees to get each subsequent tip. Now, if you go to my website, real quick, and then I'll let you guys go. If you go to my website, Math 135, videos, Chapter 8 videos, check it out, you guys. There's, if you want, the derivation of a parabola. There's more examples of completing the square. There's more examples you don't necessarily need, but look, here's examples of graphing a cardioid, graphing an inner loop limacon, graphing a rose curve the long way. I show you a more precise way to do it. And then sketching a rose curve, a somewhat sloppy shortcut. That's what I just did. But if you want another example, sketching a rose curve, a shortcut, n is odd, one where n is even, one where n is odd. There's all kinds of extra examples for you on the website, not on YouTube.